In the Precision and Accuracy Lab, we're going to talk about how to measure different volumes of liquids in the different pieces of glassware that we have, both accurately and precisely. So the three pieces of glassware you're going to be working with are beakers, graduated cylinders, and volumetric flasks. So let's take a look and let's think about how each of these pieces of glassware would work. So let's take, for example, our beaker. So we have a beaker, and we're going to use one of our 100 or 150 milliliter beakers that we have in the lab for this lab. So I'm going to draw my beaker here, and I have markings for 20, 40, 60, and 80 milliliters if I'm using the 100 milliliter beaker. And then there are markings that go halfway in between. And let me actually make that one. Closer to halfway in between there. So let's say, for example, that I have my beaker, and let's say that I walked into the lab that day, and for some reason all of the glassware is gone except for the beakers. That's the only glassware I can find in the lab. And I need to measure out 20 milliliters of a solution. Okay, if I need to measure out 20 milliliters of a solution, I have a marking on my beaker for 20 milliliters. Similarly, if I wanted to measure out 30 milliliters, I have a marking halfway between the 20 and the 40 where I could put my 30 milliliters. Now let's say that I want to do about 25 milliliters. Well, if this is my 20 mark and this is my 30 mark, if I want to do about 25 milliliters, I can go about halfway in between there. And I can do a fairly decent job of estimating that that's about 25 milliliters. Now let's say I want 22 milliliters. Well, this is my 20 mark, and I can kind of estimate halfway between 20 and 30. So I can say, maybe about just above the 20 would be 22. Now, I'm not going to be very accurate about that because I don't have a marking for 22. I only have markings for every 10. I have markings at the 20 and at the 30 and at the 40. So I'm really estimating if I want to do 22. Now, what if I wanted to do, for example, 22.5 milliliters? How do you think we would go about doing 22.5 milliliters? I asked this question in class one time, and a student told me good luck. And this student was correct. If I wanted to do 22.5 milliliters in this beaker, I'm pretty much kind of out of luck because this beaker just doesn't have enough certainty, enough precision for me to be able to go to that precision. So, my beaker is only good up to about plus or minus 1 milliliter. So if you read through your lab handout, you'll see a discussion of absolute uncertainty and relative uncertainty. Absolute uncertainty is a function of the measuring device. In our case, the beaker, we can only get up to about the 1 milliliter. And even then, we're estimating if we don't want right on the tens place. So our absolute uncertainty in a beaker, because of the way the markings are labeled on a beaker, is going to be plus or minus 1 milliliter. Now let's take this a step further, and let's think about our graduated cylinder. So we used our graduated cylinder previously, in the density lab. So let's kind of zoom in on our graduated cylinder. So I have my 20 milliliter mark, and I have my 30 milliliter mark, and I have the longer mark for my halfway in between, which is my 25 milliliters. And then I have 1, 2, 3, 4 markings there for each individual milliliter in between there. So let's say this is the only glassware I have access to. And let's say that I want to measure out exactly 25 milliliters. Well, I have a marking for 25, so I can do that. If I wanted to measure 22, again, I have a marking on 22, I can do that. If I want 21.5 milliliters, I have a marking for 21 and 22. And let's zoom in even further on this graduated cylinder. Just to make it a little easier to see. So here's my 20 milliliter mark, and here's my 5, and then 1, 2, 3, 4. So I kind of really zoomed in there on my markings between the 20 and the 25. So let's say that I want 21.5 milliliters. Well, this mark here represents 21, and this represents 22. So I can go about halfway in between there and estimate that that would be about 21.5. Now, I am making an estimation on that last place, but I can clearly read the 21 and the 22 because I have markings for that. So I can kind of estimate that, and it might not be exactly on 21.5, but it's going to be fairly close. Now let's say that I want 21.2 milliliters. I can go just above the 21 and get 21.2 milliliters. Now let's say I want to take this a step further. I want 21.26 milliliters. Do you think I can do that accurately in this graduated cylinder? That's going to be pretty tough because I'm having to estimate the tenths place. If I'm estimating beyond that, I'm really getting into making some assumptions here, which are probably not going to be accurate. So the graduated cylinder is good up to the ones place, and I can estimate the tenths place. But that's about as far as I can go. So my absolute uncertainty in a graduated cylinder is going to be plus or minus 0.1 milliliter. So on your report sheet, in the absolute uncertainty column, in table 1, you should be recording for the beaker plus or minus 1 milliliter, and for the graduated cylinder, you should be recording plus or minus 0.1 milliliter. Now let's take a step here and talk about, take this another step further, and talk about our volumetric flasks. Now, volumetric flasks are designed to measure out a precise volume of liquid, and they only measure out that volume of liquid. So, for example, in this lab, we're going to use a 50 milliliter volumetric flask. So, if I look at my 50 milliliter volumetric flasks, and we're just going to pretend that that's a volumetric flask because we know that I am a chemist, not an artist. So, if this is my marking for the 50 milliliters, I can measure out precisely 50 milliliters. Now, when you get your volumetric flask, do not fill the volume all the way to the top, because that is not 50 milliliters. Where this mark is, and you'll see a marking on your flask, that is 50 milliliters. So what you want to do is you want to fill your flask up so that the meniscus, the curve, you want the bottom of that meniscus to be right on that 50 milliliter mark. Now, if you look at a volumetric flask, most of them give you the absolute uncertainty or the error on each of the volumetric flasks. So if you look at our volumetric flasks, they have an absolute uncertainty of plus or minus 0.05 milliliters. So in the volumetric flask row, in the absolute uncertainty column of table 1, you're going to record 0.05 milliliters. So now that we have our absolute uncertainty, we are going to talk about relative uncertainty. So now that we have talked about absolute uncertainty, let's talk about how to calculate relative uncertainty. So relative uncertainty is our absolute uncertainty, and I'm going to abbreviate this so that I can fit it on the slide here, is absolute uncertainty divided by, your lab handout says the mass of an object, but we can also talk about the volume of an object. So, you're going to take your absolute uncertainty for each one of your pieces of glassware, and you are going to divide it by the volume of water that you obtained. So, you're going to take the absolute uncertainty, and then you're going to divide by the volume of water for each of your pieces of glassware. So that's how you're going to get your relative uncertainty. Now, where did we get the volume of water from? Do not just record 50 milliliters, because that is not the volume of your water. What you're going to do is you are going to determine the density of water, and then you're going to calculate your volume of water using the mass of water that you had. So, for example, if you have your beaker, oops, I didn't want to go that slide. If you have your beaker with 50 milliliters of water in it, what you're going to do is you're going to get an extra beaker out, and you're going to put some water in it. I say fill your beaker about halfway, and you're going to get a thermometer out of your drawer and stick it down in your beaker. And you'll want to let it sit for a few minutes so that the thermometer has time to equilibrate and actually be reading the temperature of your water. And then you're going to record the temperature. Now, once you have the temperature, what you're going to do is you're going to go to this table that's in your lab handout, and you're going to determine the actual density of water. So last week in our density lab, we just used 1 gram per milliliter. But this week, we're going to use the actual density to a precise number of figures. So let's just say, for example, that you measure the temperature of your water and you find that it's 23.6 degrees Celsius. Okay, this is just an example. You're going to get your actual temperature in lab. So, we have 23 degrees. So if we go down our side here, we have the whole number of degrees, and then across the top we have the decimal. So we're going to go to 23, and then we're going to go across to the 23.6. So this is where 23 and 0.6 meets. And I find that at that temperature, the density of water is 0.997394 grams per milliliter. So once you have the density of water from your table, to get the volume of water, I think my pen has stopped working on me. Oh, come on. Okay, to get the volume of water, what you're going to do is you're going to take the mass of water that you recorded, and you'll have to fill in your mass, and you're going to take the density of water, and we know grams has to go on the bottom, so it's going to be the density of water per 1 milliliter. And this will give you your milliliters of water. So, this number here is the mass of water that you measured. And this is the density of water from the table. And this will get you your actual volume of water. So you're going to do that for all three masses for the beaker, all three masses for the graduated cylinder, and all three masses for the volumetric flask. Then once you have your volume of water, you can go back and take your absolute uncertainty for each piece of glassware and divide by the volume of water, and then you need to multiply that by 100 to make it a percent, and that is going to give you your relative uncertainty. Now, once you have done that, you will need to calculate an average percent error and an average relative uncertainty. So to calculate the average, what you're going to do is you're going to take each of your three measurements and you're going to add them up, and then you're going to divide by 3. So you're going to do that to get your average percent error and your average relative uncertainty. Now once you have all of that, what you're going to do is you are going to answer the discussion questions. So you're going to answer which piece of glassware gave you the lowest percent error and which gave you the lowest relative uncertainty. And that's going to be simply looking at those averages you calculated and seeing which piece of glassware had the lowest percent error and relative uncertainty. Now you're going to answer in 3 and 4 which piece of glassware is most accurate and why, and which is most precise and why. So you'll want to review your definitions of accuracy and precision and then use that to answer those questions. So 3 and 4 may have the same piece of glassware or they may not. And then the last question, question 5, asks you, do any of the measuring devices give you so much precision that you do need to consider that the density of water is slightly less than 1 gram per milliliter? So do we really need to get our density from the table? Or could we have done like we did in the density lab and just set 1 gram per milliliter? So think about that as you're doing your lab, and think about how much precision these pieces of glassware are giving you. So that's what you want to take into account. So that is the precision and accuracy lab, so make sure you've read through your lab handout and make sure you have submitted your purpose and procedure on Canvas, and I will see you in lab.